So let's take a look at this one, and we'll do this all the way through. So my f of x equals negative x to the fourth minus x cubed plus 2x squared. First thing I'm going to do is I'm going to factor. So I'm going to take out my negative, and, oops, let's do this again. And also take out an x squared. So I'm left with x squared plus x minus 2, negative x. And so my x squared plus x minus 2 factors to x and x. I need a 2 and a 1. And since I need a positive 1 and a negative 2, then that means I need a positive 2 and a negative 1. So my zeros on my x-axis are going to be 0, negative 2, and 1. You set each one equal to 0. That's where you get all of these down here. Okay, so now there's only, oops, I forgot the squared on here. So now let's look at the multiplicity. So at 0, there's multiplicity of 2, and everything else, there's just one of them. So we're going to go ahead and graph. Okay, so when I have to graph these, I have 1 at 0. And when I have multiplicity, sometimes you can write just underneath it, I have a multiplicity of 2, so that in my mind, when I go to graph these, I can kind of remember that I need to basically bounce off of it instead of go through it. It just kind of helps you keep them straight, especially if I give you one that has a ton of them and you have to remember which one is which. It kind of helps if you just make a little mark on there, and I don't care if you do. Then we have 1 at negative 2 and 1 at 1. Now to graph it, we're going to look at our original equation. I have a leading coefficient of negative 1, which means my graph is going to point down on the right. And if I have 4, then I should have 3 humps for my graph. So we're going to start down. And I'm going to go, if I approach this and there's only one, I'm going to go through it. When I approach one with 2, I'm going to bounce off of it. Then the other one I'm going to go through. And that is my general sketch. On these problems, when I have you do a general sketch, you can just do this on regular paper. You don't need to do this on graph paper yet, because I'm not actually having you find maximum or minimums for these. I just want a general sketch so that you can see what the shape of the graph looks like. When you get to calculus, she's going to have you do first and second derivatives in order to find those points accurately and graph it. But right now, we just want to make sure that you understand how to do a general sketch and to get some end behaviors and get some other properties for your graphs. Next one, f of x equals x to the fourth minus 3x squared minus 4. I can't take anything out. However, I can, let me change colors, factor into x squared and x squared, 4 and 1. And if I want a negative 3 here, I need a negative 4 and a positive 1. Okay. So this means that I have, this will also factor to x minus 2, x plus 2. The x squared minus 1, or x squared plus 1 does not factor. So you're going to get x equals 2, negative 2. And then this x squared plus 1, let's talk about this. We get x squared equals negative 1. When I square root the x squared, I'm going to get x equals plus or minus I. Okay? Which means if I see plus or minus I, those are imaginary. So this gives you 2 imaginaries, 4 zeros. So it means you'll have a U-shaped, but it doesn't go through your x-axis. So in other words, when you approach the graph, you're not going to go through it. You'll kind of come before it and you'll bounce off. So it will be above or below it, the U-shaped part, it just won't hit the x-axis. So right now, you're just going to estimate where it is. I don't want exact. You have to do a little bit more calculus before you can get exact points. Right now, we just want you to understand visual parts of what it would look like on a graph if you have imaginaries. So let's go ahead and graph that one we did on the last page. So I have x minus 2, x plus 2, then x squared plus 1. And so we knew these were two imaginaries. So the only thing we're going to be able to plot here is a 2 and a negative 2. So I have one at 2, I have one at negative 2. And I know that I'm going to have imaginaries. And right now I'm going to put them in the middle. And I know that my right end behavior should be pointing up because the original one was positive. And since it was even, the left one should be pointing up. So your graph, your points have to be, we're going to put them in the middle. So somewhere in the middle, and do it like this. So right now, we're going to put your imaginaries here in the middle. You don't want to go through this and then do it up here. Okay, let's look at the next example. So this one, I'm not going to have you multiply out. I'm just going to give you a big long graph and ask you to do a general sketch of it. Okay, just to see if you understand all the properties. So x minus 2 gives me a 0 of 2. X minus 3 is 3. X will give me a 0 of 0. X plus 1 will give me 1 of negative 1. X plus 3 will be at negative 3. X minus 6 will be at 6. So I'm going to give you a big long one with all of these on them just to see if you can just draw a basic equation. So 0, I'm going to make this darker. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, and right now I'm not really concerned with how high you make your maximums or your minimums. I just want a general shape. The other thing you need to take into consideration is that you have a negative, which means you're going to be pointing down on the right. So I'm going to do all my zeros first and then I'll come back to that. So at 2, I have a multiplicity of 2. So I'm going to put multiplicity of 2 underneath it. At 3, 0, and 0, I just have one of them. So I have 1 at 3, 1 at 0. At x plus 1, there's 3 of them. So I know I need to go through that to where it looks like a cubic. So then I have another one at negative 1. There's 3 of them. Then I have another 0 at negative 3. There's just one of them. And I have 2 of them at 6. So there's multiplicity of 2. So if I kind of mark it on my graph, I can kind of figure out where I'm going to start. I already know that I'm going to start pointing down because this is negative. My right end behavior should always match that sign regardless of what equation I have. The left will not always match, the right always will. So I'm going to start graphing this down on the bottom right, and I'm going to go from right to left. So when I approach a multiplicity of 2, that means I'm going to bounce off of it. When I approach 1, I'm going to go through it. Multiplicity of 2, bounce off. Multiplicity of 1, go through. Now when I hit a multiplicity of 3, try and make it look like a cubic, and then negative 3, go through it. So I should have, it should look like a line going through negative 3, a cubic going through negative 1, one straight line going through 0, a quadratic at 2, a line through 3, and a quadratic at 2. So you're basically sandwiching a quadratic with a line, with a line, with a cubic, with a line, and with a quadratic. So if you cover up every single one of these, it should look like a quadratic at 6. It should look like a cubic at 3, at x minus 1. It should look like a line at -3, at 0, and at +3. And it should look like a quadratic at 2. And they're just all kind of sandwiched together. And that would be my general graph. All right, so to summarize everything we did with your end behavior, if the exponent of the leading coefficient, meaning that number in front of your highest degree, is odd or even with a positive or negative leading coefficient, then this is what the end behavior looks like. So if you have a positive number in the beginning, if you write an equation and you have a positive number at the beginning and your exponent is even, then this is what your end behavior is going to look like. It's going to point up on the right and it's going to point up on the left. And if it's negative, it's going to point down on the right, point down on the left. You'll notice that whatever this sign is, it matches the direction of your right end behavior. And notice too that when it's even, if it's an even exponent for your leading coefficient, they both are going up or they're both going down. They go in the same direction. So end behavior is the same direction. End behavior. If it's odd, if it's positive, it's going to point up on the right, point down on the left. If it's negative, it's going to point down on the right, up on the left. So again, just like the last one, if this is positive, it should point up on the right. Negative, it should point down on the right. And on odd, it's going in opposite directions. So it's either going to point up or down on one side, and then the same thing on the other. So for odd, your end behavior goes in opposite directions. For that. And that is the end of 2.2.